Good evening, people of Earth, and welcome, at least digitally, to the Rancho Mirage Library and Observatory. My name is Eric McLaughlin, and tonight, for Swoon the Moon, we are going to be taking a nice look at the moon with a number of different instruments and talking in a bit of detail about different parts of it. Anyway, thank you all for being here. We're really excited to have you, especially given the fact that, well, we can't actually have you here on site right now. So again, thank you for taking the time to join us here tonight. And with that special thank you, I also want to give a special thank you to the Rancho Mirage Library and Observatory Foundation. It is through that foundation that we're actually able to offer events like these entirely free to the public, and thus, again, a special thank you to the Rancho Mirage Library and Observatory Foundation. So as we are getting things set up and ready to go here tonight, I want to just note a few things. I am working with a lot of different pieces of equipment here tonight, and in doing so entirely by myself, practicing fully fledged social distancing rules here. So it'll take quite a bit of finagling to get everything to cooperate. So as we get in, if there are any vocal pauses or noticeable pauses or anything, those are just some things we'll have to deal with. But as we are going, I also have the chat turned on, so if you are interested in asking some questions along the way, I am not alone there because our wonderful observatory coordinator, Lauren Zuckerberg, is in there. She will address any questions that I'm not able to get to directly. And also note, there is a little bit of a sound lag, so you'll be hearing me a little bit after I'm actually saying these words, so there might be a little bit of time between when you ask a question and it is answered. And with all that said and done, speaking of virtually being here, we also have a virtual view from here, so we'll go ahead and transition right over to that. Here it is worthwhile to actually use the virtual systems we have here to actually allow us to see a few other things, including things like the constellations. And we can also put on the orbits of different planets, as well as a few nice guidelines in our sky. And it's also worthwhile to put a nice grid showing exactly where we are looking in the night sky. And as we're looking here tonight, we're going to be spending just about all our time here in the solar system, but our main source of interest right now is just crossing the meridian, that line extending from south to north in this viewpoint. That object just crossing there is, of course, the moon. And so we will focus on it right now. As we zoom in to take a closer look at it, you can see the moon is squarely in the constellation of Gemini right now, and it is half full. And that is why we always have our Swoon at the Moons at this time, is because a half full moon gives us a lot of varied shadowing on the moon. That gives us a lot of worthwhile things to take a closer look at. Now, as we are getting ready to go here, it is worth talking in some detail about what we will specifically be looking at. And there are a few things we can see a bit more directly by actually not just looking at this particular view of where the moon is in our sky, but rather also looking at some specific details on the moon itself. So we'll go ahead and swap over to this nice view from the Science Visualization Service over at NASA. They develop this every year, and it gives us a lot of really nice things to look at, things to really better understand what we're looking at when we're looking at the moon. Now, the moon is quite a long ways off from the Earth, and this particular view has a nice little hidden map in it, and it's actually to scale. No, not this one up here. That one's not to scale. Down here, this is the moon to scale, or sorry, the Earth to scale with the moon over here. And with that, note it is actually positioned in scale as well, with the moon being right near its average distance away from us at around 37 to 38,000 kilometers from the Earth. Being told I have a little bit of a staticky audio. I'm trying to do my best to adjust that. Let me try a different microphone, see if that makes any difference. Okay, is this mic any better, or is this just as staticky? That is really what I want to know. I want to make sure you guys can hear me very well without a lot of problems. All right. While I wait to hear back from you guys, I will keep noting a few things on our particular view of the moon here. Now, as the moon is half full, there's a very important line to note on the moon. This line right here is, in fact, known by a special name. It is known as the Terminator. One second while I continue to try and use this microphone because I've been told it is better. Alright, something's behaving a little weirdly, but we'll go ahead and go as is. Now, back to this particular view of the moon. This one allows us to see a lot of different highlights, including things like specific lunar landings, like the Apollo 11 landing here, as well as we have Apollo 17 on the other side of the Sea of Tranquility. And among the other things worth noting is actually this diagram in the upper left of your screen. This diagram shows in particular the geometry of what's going on here, where we actually have the lighting of the Earth demonstrated very well coming from this direction here. And this point here is known as the Point of Aries, which it's not associated with the constellation of Aries anymore, though it used to be where we actually had the where the sun would be, the direction of the sun, I should say, right at the vernal equinox for us here in the northern hemisphere. And that's why the sunlight is coming just past that, because we actually just passed the vernal equinox here last month at this point in March. Now, with that in mind, it is worth seeing the specific geometry. Why is the moon half full? Well, because if the moon is right here, and the Earth is here, and the sun is off in this direction, we have just about a right angle going between the sunlight, or where the light is directed towards the Earth, and our view towards the moon. So, we see half of the moon lit, and half of it unlit. And so it is worth noting a few things when we're looking at the moon, but we want to get looking directly at the moon here soon, so I have to go and make a quick adjustment, and we will be ready to do that. Just making some adjustments to a telescope. Want to make sure you get a good view. It will be up in just a second. Alright, we'll go ahead and switch to our small telescope view. It's a little bit bluish for some reason. I haven't quite gotten that squared away. Nevertheless, our view here can give us a nice ability to see a lot of different features, including, again, that Terminator line going right from the North Pole down to the South Pole of the Moon. We can also see the seas really apparently. We have the Sea of Tranquility right here with our first lunar landing right about in this area here. We'll take a closer look in that direction, but we still won't be able to see the landing site itself because, well, it is really worthwhile to understand exactly what scale we're looking at here. I've got a quick little view to let you see exactly what I'm referring to when I say that the moon itself is quite large. To really get an idea of how large the moon is, well, it's worthwhile to actually compare it to a very specific map. And that map is one of the United States. We'll go ahead and pull that up right now. This view here is a map of the United States as viewed in Google Earth, but I've traced out a nice red circle on here which has a radius of the average radius of the moon. So when we're looking at a full disk view of the moon, it is worth actually considering just how big of a scale you're looking at. So if you're looking at a full disk of the moon, don't expect to see something really small like a American flag or a lander itself. Those features are just too small to really spot using equipment here on the ground. Alright, and right back over to the moon here again. This particular view again gives us a good feel of the full scale size of the moon. There's a reason why it has been referred to as the Earth's eighth continent, because it is, well, quite comparatively in size, that is in surface area, not all that far off from being continentally in size. So it is an interesting prospect for future exploration to try and actually go and take a look over at the moon. Now, while we've got a nice good amount of contextual views here, it is still worthwhile to take a much closer look at the moon, and to do that we got to get the main dome opened up and the telescope set up as well. So let's go ahead and start doing that. You've got a nice view of the interior of the dome over here on the right, and I'm going to point out some things over there as we start opening things up. I've swung the telescope over down where we can see it, and I've opened up the dust covers so we can see inside. If you look carefully there, you might be able to spot the main mirror of our Planewave Instruments CDK 700 telescope. It is a wonderful telescope, and capabilities-wise, it's actually a little bit overkill for looking at the moon, but nevertheless, we're going to have a good view looking through it. And so I'm going to go ahead and start the dome opening up and get the telescope back on target. As you can see in the right hand of your screen, you can see the dome starting to open up. Once that finishes opening up, we will go ahead and open the dust covers back up on the telescope itself so we can actually get a good view of the moon directly. And in preparation for that, we're going to switch over to our main camera for that telescope. It will take a little bit of time for that to actually get there. That is a picture I took earlier, so that is what we can actually expect. At the moment, this is what we're actually looking at. So once that whole upper shutter gets opened, once that is completely opened, we can go ahead and open up the petals covering up the telescope mirror once again, and we should have an image appear over here right at that moment. Almost there. You can see now the petals of the telescope opening up, as well as that last section of the dome folding outward, and as it opens up, we start to see the moon shining in our field of view here. And we're going to wander around the moon here for a bit. Give me just a second while I begin positioning the telescope. From this particular view, we are looking near the southern pole of the moon. The southern pole being down here where there's a really interesting crater we want to visit called Shackleton Crater. It's named after a specific expedition to the South Pole, and that one didn't go so well, but fortunately everyone survived that particular journey, which is wonderful news for a seafaring voyage whose ship got crushed in ice. So it's wonderful that they survived the Shackleton expedition, and it is wonderful that we actually have an interest down here, not for ice that can crush ships, but rather for the fact that that crater has a section that is fully in darkness all month long, all year long, perpetual darkness there. Thus, there is expected to be some ice. We've actually detected some ice there that could potentially be mined and used for spacecraft fuel and other things. And so we're really interested in visiting that spot down there. Now, among the other things worth noting in this particular view are some craters like this one right here. This is Tycho Crater. And Tycho Crater is a wonderful feature that is about 84 kilometers in diameter. And to put that into perspective for those of us here in the valley, that is the Coachella Valley. The Coachella Valley itself is on the order of around 70 or so kilometers long, stretching from near Banning all the way down to the northern coast of the Salton Sea. So, in a nice size comparison, this particular crater is about as wide as the Coachella Valley is long, in fact a little bit wider, and it's actually about 5 kilometers deep, so it's deeper than the valley as well. However, as we're looking down towards the southern end of the moon, we are actually also looking at the moon's Highlands. There aren't any seas here as they're referred to. Those seas aren't actually bodies of water, but they are named after them. They tend to actually just be basins that actually filled in pretty heavily with lava. Now, while we're looking at this particular view, we're going to be stopping at a few different features here. I will note there's some fun things we actually are getting available now as it is starting to get a bit darker outside. Once the sun passes below minus 10 degrees below the true horizon, the all-sky camera turns on, and I'm going to swap over our view on the right from our weather station to our all-sky camera. From this point, I'm going to wander on a bit further north because there are some nice features that we can spot along the way up there. where we are looking now, we have the Sea of Serenity, Mare Serenitatis, towards the upper right of the frame, with the Sea of Tranquility towards the bottom of the frame there. And if we nudge ourselves down a little bit more, where down is eastward in this case, roughly, east from our perspective on the Earth, I should note. On the Moon, it would be, if you were there, moving a bit further west. All the fun things about perspective on planets and moons. Increase the exposure time to give us a little bit brighter view, but as it does that, it also means we get a little bit of longer exposure, which shows a little bit more of that distortion in our atmosphere. That's why you see a little bit of dancing going on in the image there. Now from this particular view, we've got the Sea of Tranquility well highlighted right down here, and in this particular area again is where the Apollo 11 landing first occurred, or only occurred. The other Apollo landings occurred in a number of other places, but Apollo 11 landed roughly right around here, and so again, don't expect to see a flag from any particular view we've got here. That is the best we are going to be able to get, and that is again because the Moon is on the order of 370 to 380,000 kilometers away, as we can remind ourselves from that particular information slide view where we had the destination, or the particular map. Really quick, I can hop back over to it if I set this up right. There we are. Again, we are quite a long ways off from the Moon. We're looking from here all the way out over to here, so we are not really going to be able to spot tiny details from this particular view here. Back to our other view though, there we are. And in this particular view, we can see where some other landing sites actually landings did occur. We again have the first Moon landing being roughly in this area here. While the last lunar landing, Apollo 17, was actually right over in this region here on the other side of the Sea of Tranquility, actually up in the Highlands there, which actually meant it was a bit more of a challenge to land. And when it came to the Apollo landings, there was a lot of planning involved for how they would land in their different areas. Really, they started down here in the Sea of Tranquility for good reason. They were very close to the Moon's equator here, and this region is very flat, and thus it was deemed likely to be a relatively safe place to land. They continued to escalate things along the way up to more and more challenging things up until landing in the Sea of, or above, north of the Sea of Tranquility in the mountains up there. And that was the only mission that took a dedicated geologist with them, someone who studied geology primarily, rather than being more of a test pilot along the way, as it were. Now, from this view, we can also make a couple little adjustments to find some other landing sites and some other really nice features. up here by the Terminator, we have some really nice things we can spot because of a lot of really nicely cast shadows. Right in the center of our screen here is Montes Apenninus, a mountain range that has 3 main peaks in it. We have Mons Wolf down here, Mons Huygens towards the center, and Mons Bradley towards the northeast. Off the end of this particular feature here is a really neat crater that actually is wonderfully casting a shadow right now. Why is it wonderful that it's casting a shadow? Well, that crater is the crater Eratosthenes, and Eratosthenes is famous for having been a librarian in Alexandria in around 200 BC. He was actually able to use shadows cast to actually get a quite accurate measure of the circumference of the Earth. And so, in particular, he was using a well that didn't have a shadow cast in it on one particular day of the year. That was the summer solstice, so we are about halfway between the winter solstice and the summer solstice now, so we will eventually have the sun nice and high in our sky, but he was able to use shadows cast into a nice pit, as well as a very dedicated person he paid to go and count their steps all the way to that well, some 700 kilometers or so, if I remember correctly. And as such, with just some basic measurements, he was able to get a good, accurate measurement of the full circumference of the Earth. However, Eratosthenes isn't the only crater named for an ancient philosopher. We also have this crater right over here, named for good old Archimedes. And there are a few other craters right around this area here in what is called the Mare Ibrium, or the Sea Ibrium. And it is another nice flat region, but there is a number of good distinct craters because, again, of our specific lighting we have on the moon here right now. Just to the right of Archimedes, we have Autolycus, and we have Aristillus here. And right up in the corner of our view, right up here, is actually Cassini, where Cassini is named after an astronomer who did a lot of work studying actually Saturn, as well as some other things as well. Now, there is a nice crater named here on the moon for someone by the name of McLaughlin, but I will say not visible right now and not related, so I can't claim any credit for that. But in any case, I always like to point that one out. Another good reason to end up in this part of the moon here is because we are actually not far from where the Apollo 15 lander set down. It was actually right near the highlands of this particular mountain range again. They set foot right about down here, again, right by the Montes Apenninus. And this particular mission was a really important one. It was the first one that actually landed right near quite a bit of the Highlands, but it also brought with it the first lunar rover. There were only 3 missions that actually took a lunar rover with them, 15, 16, and 17. And so this being the first really dramatically improved their ability to explore a section of the moon's surface. There's another little thing they actually landed by right there. Unfortunately, it's a little bit too small to spot, and our atmosphere is giving us a little bit of problems for spotting these. But it is a Ryle, actually what is believed to be a collapsed lava tube around that particular site there. Now those collapsed lava tubes are really interesting to note because, again, when we're looking at the moon, the biggest distinction of regions are the seas and the highlands, where the highlands are actually areas where the crust of the moon was a bit thicker in times past, and as such, there was a period where these areas filled in dramatically with a lot of lava and thus created that nice flat surface there. As it created that flat surface, it also covered over quite a bit of other things, but that lava did have to cool, and so there were a lot of little channels or riles made, and those riles actually provide some interesting, thought-provoking sites to potentially explore because, well, when we're looking at the idea of potentially trying to build settlements or colonies on the moon, there's a number of challenges to that, one of which is micrometeoroids, another of which is radiation, and some think that maybe some of those lava tubes might actually still be intact, and so some propose actually trying to build their habitats inside some of those particular lava tubes. Now back to a full disk view of the moon here. I want to head somewhere else. Normally I don't do this for Swoon the Moon, but it's a great time to actually note something else that has phases from our perspective here on the Earth. This particular view we have of the moon now puts it at about first quarter phase, what we would refer to as a waxing moon. It is getting more and more full. Thus that region of the Terminator there is where sunrise is happening on the moon. Now there is also the opposite side of the Earth where we get third quarter, and that is where the moon is getting less and less full. And there's another object in the solar system from our perspective, actually there's a couple of them, but one in particular has a really nice ability to have its phases viewed, and as such, I kind of want to take a quick swing over and visit Venus, which just past its, well, what we would kind of refer to as third quarter. It is just getting less than half full now, and so we have a very good detailed view of that particular phase. However, and I want to hamper your expectations there, because Venus is so much further away from the moon, we will have much less detail there, and in fact it is covered by a thick layer of clouds, and so we will be looking primarily at the phase of Venus when we get there. So give me just a second while I adjust the telescope over to that planet. It'll take a second for Venus to pop into frame as the dome is moving. You can see it moving right there. Venus will pop right into frame, and it will be nice and small, but this is where we will note quite a bit more of that atmospheric disturbance as Venus is much lower in our sky here. There she is. Let me go ahead and get her centered in there. I apparently hit the wrong button and scrolled right past Venus. Excuse me, sorry about that. Whoops, the dome would have figured that out in any case eventually, but it's good to be back on target here. With Venus back in the center of our field of view, you can see very clearly that nice flat line along this side of it here. That is the Terminator on Venus on its cloud tops there. So the sun-facing side is this direction here. And as such, it is important to note that this particular view, along with the last one we were just looking at, were really crucial to just plain understanding our solar system. When it comes to understanding the solar system, it is important to know that, well, first and foremost, the sun is at the center of the solar system. And while there was a lot of discussion and mathematical modeling going on in the late 1500s, early 1600s by people like Johannes Kepler and, well, in this case, Galileo Galilei, he was actually much more using the observational techniques we're using right now. We're using a telescope, and he also used a telescope which allowed him to see those craters and mountains and other things on the moon, showing that the moon was not a perfect sphere as the philosophy of the time suggested. And also he was able to observe the phases of Venus. And now as Venus is at right near its point of being as far away from the sun as it gets, right near half full, those points, and when I say as far away from the sun as it gets, I mean in our sky, from our perspective. Over the course of the next month or so, we will actually watch Venus get brighter because it's going to be getting closer to us, and it will also become much more of a crescent shape as it does so. So if you have any sort of telescope, you might want to take repeated looks at this bright shining object. And that bright shining object is really easy to spot in our sky. When we are looking up into the sky, it is quite easy to spot this. Why? Well, because it is actually nice and bright. So we'll let's swap back over to Stellarium and see that particular view there that we had. Here's where we were looking over at the moon, and this is a great particular view of the moon. However, if we zoom back out from the moon is nice and bright and shining in our sky, but over to the west, we will spot something nice and bright as well. Just north of the ecliptic here, this line here really is the line that the sun actually points at, or moves along over the course of the year, and so this particular line also maps out roughly the plane of the solar system here. And now we can see Venus is right in the sky, right next to the Pleiades right here. So let's go ahead and zoom in right on to Venus here. Now, while we're looking at Venus here, we can see again that it is near its furthest point away from the Earth in its orbit. We can actually hide the ground here to see that a little bit better. With this particular view, we can see that Venus is quite a long ways away from the sun in our sky, and that is something that really makes it nice and unique because it ends up very bright in our sky because of those cloud tops, and it also happens to end up being seen always either near the sun during the morning or the evening, and that is how it earned that name, the morning and evening star. And it does on occasion get pretty close to the sun, and twice every 100 years it will actually be seen to move in front of the sun directly. Unfortunately, that won't happen again for a long time. The last time it happened was 2012, and the two times it passes in front of the sun happen about 6 years apart, and that one in 2012 was the second time this century, so we are going to have to wait quite a while before we see another transit of Venus. Anyway, back to Venus itself, it is really great to be able to actually see some different perspectives on things like this. And so it has been a lot of fun wandering around the moon and taking a quick look over at Venus as well to give us an idea of, well, our little spot here in the solar system. I know we are in a unique time right now where we are actually well established in our particular little spots here, and by that I mean largely isolated. And yeah, when we look out at the universe around us, it might even feel even more isolating, but nevertheless, it is worth also putting things into perspective. While we might be a little bit further away from friends and family than we might like right now, it is also worth noting that these objects we've been looking at here tonight are so much further away from us that really, in the perspective of the solar system, we're all right next to each other. We're all right next door. So I hope that as we wrap up here tonight, that you're able to actually take this large-scale perspective and actually think about the fact that we are not all that far off from each other. We will come back together here soon, and I hope that we've had a lot of fun here tonight looking up at the moon. I'll get one more full disc view of the moon here in just a second, and then we'll wrap things up. And from one object with phases back over to another. So again, thank you for being here tonight. We hope that you had a wonderful time. There's a lot to see out there. The moon itself is a grand and vast place. And so hopefully we get to explore it a lot more here in the near future. There's a lot to be excited about, and we can expect to get a chance to, well, maybe see some of that here soon. So hopefully we can just be all kinds of excited about the near future. Anyway, again, thank you all for being here. I hope you all have a wonderful night, and keep yourselves safe, and also keep on taking a look up at the night sky whenever you get the chance, because there's a lot more out there than we